Welcome back again to this series where we go through all the different very tricky problem-solving questions and I explain exactly how to do them, what my thought process is, in the hopes to make it more likely that in the actual exam or in your mocks or whatever you're preparing for, you will be able to score those top grades and top marks. But again, before we get into the video, if you could please consider subscribing if you've ever found any of my videos useful, it really does help me out. But without further ado, as promised in the last video, I said that we'll go through another type of vector question where instead you have to work out the ratio. So the name of this video might be a bit odd depending on what I decide on, but it's like a vector question where you have to prove that there's a ratio and the ratio is missing, it's an unknown. Not too sure what to call it, so let's see what I come up with. But essentially, these missing ratio questions can be very tricky, and this one actually has something a bit scummy at the end as well, because the value you find, you have to do something to it to actually find the proper value, which I think is a bit annoying, but whatever. So let's have a look. So we have a parallelogram. What does that mean? It means the opposite sides are parallel, so it means A to B is also C, and C to B is also A. We're probably not really going to use that. We could use it though, but I don't think we need to. X is the midpoint of the line AC, so again, let's add that on. Draw a straight-ish line. I love Microsoft so much. And X is over here. And OCD is a straight line, so that, okay, so we're going to have a and we have another point D here, such that OC to CD is K to 1. Now, the way I like to write this is, because this is a straight line, it means that O to D is going to be some multiple of C. And likewise, C to D is going to be a multiple of C. Why? Because they're all along the same line. So it's like they're along a ruler, right? It's a certain multiple. So the letter I like to use is lambda. So I'm going to say C to D is lambda C, and O to C is just C. Why do I use lambda? That's a really good question. At university, when I was doing kind of vectors and all that kind of stuff, we like to use the Greek letters when we deal with it. So things like lambda, mu, etc. You will use them a lot in A level. It's just a convention. If you want, you could just name it the letter Y, C. It really doesn't make a difference. The other reason why it can be useful is we tend to use the Latin alphabet for the actual points. So when I write YC, some people think that I mean point Y, and they say, well, where's Y? Whereas if I use lambda, it makes a bit more sense. But again, it's just a letter. It represents a number that I don't know. I could write it in like an Arabic letter if I wanted to. I could write a Greek letter. I could write any letter I want. It doesn't really make a difference. So, what other information do they give us? They give us a very interesting thing. They give us the vector x to d. And they say that if I want to go from x to d, I need to go 3c and minus a half a. Very interesting. So, what is my objective here? Well, if you notice, I don't know what c to d is. Now I have one vector that involves c to d, which is xd. Right? That's the overall vector. So in my mind, if I write my own equation for xd and I compare it to this xd, I can then look at what the difference is, and therefore the difference should be c to d. For example, if I know that x to c is half a, for example, and I know that x to d is half a plus 3c, then that means c to d must be 3c, right? I'm just looking at the difference. I'm comparing them. It's almost like a simultaneous equation. So if I were to go from x to d, what would I do? Well, I would go from x to c, and then I would go from c to d. Now, do I know what those are? Well, x to c is half of a to c, so I'm going to write that in. 1/2 a to c, and then I know that cd is just lambda c, so let's leave it as that. Now, AC, again, just like in the last video, I need to go from A to O. Technically, I could go from A to B and then B to C. It doesn't make a difference. But I'm going to go from A to O and then O to C. Again, if you go the opposite way, you get the same answer in the end. So, because I'm going in the opposite direction to this vector, I need to make it negative A. And then I'm going in the same direction as the C, so I'm going to put plus C. Plus lambda c, boom. Now I'm going to expand it, just make sure it's all nice. So we have minus a half a, plus a half c, plus lambda c, and that's my vector xd. Now I also know that xd is equal to 3c minus a half a. So I can write equals 3c minus a half a. Now what do I notice? Well, if I move the a's to one side, so to speak, if I add a half a to both sides, you might notice that the minus a half a goes away. So instead that leaves me with, actually I'm not going to write that, that leaves me with a half c plus lambda c equals 3c. So I'm going to work out what lambda is. Now this is useful because that's going to tell me what fraction of c to d is. In other words, it'll tell me the ratio. So let's do that. If I minus a half from both sides, we get lambda c is equal to, again if you want to use a calculator, 3 minus a half is 2.5, so that's 5 over 2c. So in other words, lambda equals 5 over 2. So if I were to write this here, instead of lambda we have 5 over 2. So if I wanted the ratio of OC to CD, well, CD is 5 over 2 times bigger, so it's 1 to 5 over 2. But look at what the actual question wants. This is what I meant by the sneaky, scummy thing at the end, right? At the very end, it wants the right-hand side, C to D, to be equal to 1, not equal to 5 over 2. So all we need to do is divide both sides by 5 over 2. If you want, you can times both sides by 2 and then divide by 5, totally fine. But if you do 1 divided by 5 over 2, remember it's the whole KFC, keep flip change. So it just becomes 2/5. So the actual value for K is 2/5, not 5 over 2. Because remember, the ratio was K to 1, where the parts represented by CD should be 1, whereas we had 5 over 2. So we have to swap it round. In terms of why I put the 5 over 2 under the CD, really simple. Actually, I'm not going to say it's really simple, that's a bit rude. But here, I can see that C to D is 5 over 2 times bigger than this. That's why it's written that way. Again, very tricky question, but hopefully that gives you an idea on how to solve these ratio questions when they come up. Again, when it says question 2, by the way, this is from an actual paper, but it's from an aiming for grade 9 paper. So don't worry, the question 2 more than likely isn't going to be like this in your real exam. This would definitely be towards the end of the paper, because vector geometry be a bit difficult. Again, if you found this useful or any of the other videos useful, please consider subscribing. It's just one click and it really does help me out. Without further ado, I will see you in the next one. Have a wonderful day.